Welcome to AI ConvoCast, where we bring you the latest in AI and tech innovation. Quick housekeeping. Check out the affiliate links in our description. Using them supports the show, and please don't forget to rate, review, and share if you like what you hear. Let's jump right in.
Welcome to the Deep Dive. Today we're unpacking some really significant AI hardware and infrastructure news from June 2025. Our mission, as always, is to quickly get you the most important nuggets from these recent breakthroughs. We'll have three key areas. First, Qualcomm's new chip shaking things up for smart glasses. Then, AMD's big challenge to NVIDIA in the data center space. And finally, a partnership between TCS and NVIDIA focused on AI in telecom networks.
Yeah, and it's crucial to understand why these developments are so important. They aren't just spec bumps. They are fundamentally the enablers, the foundation that's going to shape where AI goes next, what applications become possible. We're definitely seeing the competitive landscape heat up beyond just NVIDIA, which is, really interesting.
Absolutely. Okay, let's start right at the edge then. AI literally on your face. We're talking about Qualcomm's new Snapdragon AR1 Gen 1 chip for smart glasses. Now, context here is important. Current smart glasses, they still need your phone nearby, right, for the serious processing. Power, size, compute needs, those have always been the big limitations.
Definitely. Getting powerful AI into something you'd actually want to wear all day is the challenge.
Right, so Qualcomm announced this on June 10th at the Augmented World Expo, AWE 2025. Physically, the chip itself is quite a bit smaller, 26% smaller than the last one, and that allows for maybe a 20% reduction in the thickness of the glass's arms. So slimmer designs.
Which makes a huge difference for wearability. Form factor is key for adoption.
Exactly. But here's the really big news. The breakthrough. This chip can run Meta's Llama-3.2 1B model completely on the device.
Llama-3.2 1B, that's a smaller, efficient version of Meta's large language model, right? Designed for this kind of on-device work.
Precisely. And crucially, without needing an internet connection. Qualcomm's SVP, Ziad Asghar, actually demoed this on stage. It was pretty cool. He described being at a, quote, supermarket and asking his glasses for a fettuccine Alfredo recipe for his daughter's party. And he said, quote, "This demonstration was a world's first, an autoregressive generative AI model running completely on a pair of smart glasses."
Wow. So generative AI, creating text, recipes, whatever, just running locally on the glasses. The implications there are pretty significant for you, the user. First off, privacy. Your data isn't necessarily going to the cloud. It stays right there on the device.
That's a big one.
Huge. And second, offline functionality. Think about hiking with no signal or, a doctor in a remote area needing quick information. This could really be the catalyst for truly autonomous smart glasses. Real-time translation, contextual help, all without being tethered to your phone.
So it pushes us faster towards that idea of ubiquitous wearable computing.
Exactly, a major step.
Okay, so from AI you wear, let's zoom out to the massive engines in the data center that train and run these models. AMD just made a really aggressive move here. On June 12th, they announced their new MI350 series chips. And they're not shy about it. They're positioning these directly against NVIDIA's B200 and GB200.
Yeah, AMD's definitely turning up the heat.
Their CEO, Lisa Su, made a pretty bold claim. She said the new chips are 35 times faster than predecessors.
35 times. That's a massive jump generationally.
It really is. And looking at the specs, they announced 288 gigabytes of HBM3E memory, paired with something like 22.1 terabytes per second of memory bandwidth.
Okay, let's break that down. 288 gigs of HBM3E and over 22 terabytes per second bandwidth. That significantly outstrips what NVIDIA currently offers on their B200 spec-wise.
Right. So why do those numbers, the memory, the bandwidth, why do they matter so much?
Great question. They are absolutely critical for training and running these huge, large language models, the LLMs. Think about it. These models chew through enormous amounts of data. More memory means you can fit bigger, more complex models directly onto the chip without constantly swapping data in and out. And that massive bandwidth, that's the speed at which the data can be fed to the processing cores. It's like having a super wide highway for data.
Okay, so it lets the AI do more complex things faster, like giving an artist a giant canvas instead of a napkin, maybe.
That's a perfect analogy. It enables bigger, more sophisticated AI tasks to run efficiently. Industry-wise, this obviously cranks up the competition. More competition is usually good for everyone. It can drive down prices, push innovation faster.
Good for developers, good for companies deploying AI.
Potentially, yes. Lower costs, more options.
Right.
But we do need to acknowledge NVIDIA's advantage. They have a really strong competitive moat, as they say. Their established software ecosystem, CDA, is a huge factor.
Right, the software side is critical, hardware specs are one thing.
Exactly. AMD's success here won't just hinge on the chips themselves, but heavily on building out their software support and proving this performance in real-world applications.
Makes sense. Okay, so we've got AI on the edge with glasses, AI in the core with these powerful data center chips. Now let's talk about the connections, the networks in between. There's a third big development, a strategic partnership between Tata Consultancy Services, TCS, and NVIDIA, announced June 16th.
Yes, focusing specifically on the telecommunications sector.
Right. Their stated goal is to build AI-native tools for telcos, and they're leveraging NVIDIA's big platforms, DGX Cloud for the heavy-duty AI training, NeMo, which is for building and customizing large language models, and Omniverse, that's NVIDIA's platform for creating simulations and digital twins, right?
Exactly. And that digital twin concept is key here.
Can you quickly explain what that is?
Sure. A digital twin is essentially a detailed, dynamic, virtual replica of a real-world system, in this case, a telecom network. So telcos can use it to simulate changes, test optimizations, predict failures, all in the virtual world before they implement anything on the actual physical network.
Okay, so safer, faster testing and optimization.
Precisely. Avoids costly downtime or errors. So TCS and NVIDIA are aiming to build tools like smarter, automated customer service agents, but also these sophisticated network digital twins. The significance here is how it shows AI moving beyond just, say, consumer apps or specific business tools. It's becoming foundational for optimizing the core infrastructure itself, the networks we all rely on.
It feels like AI is becoming part of the plumbing almost.
That's a good way to put it. Akhilesh Tiwari, who's president of TCS Communications, he put it this way. TCS is proud to collaborate with NVIDIA to design a broad spectrum of AI-native solutions that not only address mission-critical challenges, but also unlock new revenue growth opportunities for our telecom customers.
So it's about efficiency and new capabilities.
Exactly. Enhancing network operations, reliability, speed, all crucial as demands on communication networks just keep growing.
Okay, let's try and pull these threads together then. What does this all mean for you listening right now? We've seen Qualcomm pushing powerful local AI to the edge with smart glasses. We've seen AMD challenging the status quo in the data center, potentially making core AI processing more powerful and maybe accessible. And then TCS and NVIDIA working to weave AI into the very fabric of our communication networks.
When you connect those dots, you see the pieces falling into place for AI's next major phase. These hardware advancements across the board are the essential building blocks. They're creating the infrastructure needed for AI to become truly ubiquitous, from deeply personal assistance on your glasses to powering massive global enterprises to keeping the networks humming.
So it's not just about making AI smarter in the cloud. It's about making it more present, more resilient, more integrated into everything, everywhere.
Precisely. It enables AI to function reliably, even offline, to be embedded more seamlessly into devices, and to manage the complex systems that connect us all.
We're really watching the foundations being laid for AI to be, well, everywhere.
And perhaps a final thought for you to consider. Mull this over. Think about how these simultaneous advances, capable AI right on your person, incredibly powerful back-end processing, and smarter AI-optimized networks, how they might fundamentally change what we expect from real-time interaction with AI. We could see a future where the lines between the digital world and our physical experience blur in ways that, frankly, we're only just starting to conceive of.
A truly blended reality powered by this new generation of hardware. That's definitely something to think about. Thank you for joining us on this deep dive into the rapidly evolving world of AI hardware. Keep exploring.
Thank you for listening to AI ConvoCast. Please don't forget to rate, review, and share if you like what you hear. Thanks and hope to see you again next time.